Let's practice finding the specific heat of an object. This one says a 0.0676 kilogram ingot of metal is heated to 225 degrees Celsius and then is dropped into a beaker containing 0.418 kilograms of water initially at 20 degrees Celsius. If the final equilibrium state of the mixed system is 22.4 degrees Celsius, find the specific heat of the metal. The specific heat of water is 4,186 joules per kilogram times degrees Celsius. All right, so let's begin by writing down the given. Okay, before we move on, instead of using letters for my subscripts, I decided to use numbers. So subscript 1 represents metal, so anything with the 1 pertains to metal. Likewise, I picked 2 for water, so anything with a 2 is water. This temperature is the initial temperature of the metal, initial temperature of water. The reason why I didn't use letters here is because the final temperature of the system will be the same. We know that when two, in this case, the metal and the water, are in contact for an appropriate amount of time, they will reach thermal equilibrium. That is, they will have the same temperature. And we know that's the case because there will be an exchange of energy transfer between the metal and the water. We know that the heat flows from hot to cold, so the energy will be transferred out of the metal into the water, meaning that the energy transfer away or out of the metal, it'll be the energy transfer into the water. So that allows me to say that energy transfer away from the metal is equal to energy transfer into the water. And we know that the equation we have to use, let me just pick a different color just to have it in general. That's the equation we have to use. Now let's build two equations for metal and water. So from that's pretty straightforward. We know that these two, because the left sides are equal, then the right sides should be equal to each other. I have a mistake here in the given. Sorry. C2 is water, 1 is metal. Because we need to find C1, then all we have to do is divide. And this is the equation we're going to use. Now, before we plug numbers in, the only thing I want to talk about is how to find your change in temperature. A lot of people, well, I don't know if a lot of people, some people might disagree with me, but I'm doing this because I want my students just to be able to get the correct answer and understanding what's happening. So for your delta T1 and T2, you want to get a positive number, meaning that because we know we're going to subtract one thing from another, you should always have a higher temperature minus a lower temperature. Okay? So let's do a quick note over here. Let's go for delta T1, which describes how the temperature of the metal changes. If we go back to the given, we'll see that the initial temperature, T1, is 225 degrees Celsius, and the final temperature of the mixture is 22.4 degrees Celsius. And of course, to get a positive number, we see that 225 is greater than 22.4, so that's why we would subtract 225 from 22.4, which is T1 minus T final. Likewise, my delta T2, it's going to be T final minus T2 because this is higher than 20. Now let's expand our equation. There you have it. The reason why I want you to have this one is for some problems in your homework, we're going to have to find final temperature. Now let's plug in our values. there you have it. All you gotta do is plug it into the calculator, and you get. So that's my specific heat of this metal. I could just Google it to see what would be the metal that has this type of specific heat. I'm not gonna do that because you'll do that for your lab. That's it.